Today is our webinar for growth engineering in the age of AI. And let me introduce you our two speakers. So myself is on the bottom, YZ. I'm a data scientist at Statsig. I'm evangelist, talking about experimentation culture and how to use experimentation to grow products. So our guest speaker here is Marcos, head of engineering at Statsig. And previously at Meta, he was a growth engineer. He was Statsig right now. We just funded our Series C, and we are like a $1 billion valuation company. Marcos has been the head of engineering throughout this journey, so he has seen our growth. Alexey is the growth engineering advisor. Previously, he was the head of growth engineering at MasterClass, and now he is advisor for a lot of startups and scale-ups. His client includes Anthropic, Dropbox, and other companies. He also teach growth engineering at Reforge. So he teach a lot of students from all kinds of companies. Today's agenda, we have three topics. First, what is growth engineering? And second, growth engineering in the age of AI. And three, agentic growth loops. So without further ado, let's go to the content. Part one is what is growth engineering? Alexey, do you want to start?
Yeah, all right. So I get this question asked a lot, and I kind of struggle with it. I think I'm just going to give a reductivist answer to what is growth engineering, right? You can think of a company being divided by like the skill sets that people bring, engineers, product managers, and then the objective that a particular department has to solve. And if you go to the next slide, like the definition of a growth engineer becomes really straightforward, right? A growth engineer in the next slide is just kind of the that intersection, right? So if you keep going, we get to your job is to grow the business, which is the department's job, using code, which is the skill set that you bring. But in practice, it ends up being like a sufficiently different thing. Marcos, you want to take it from here?
Yeah. So I think the main difference here is kind of like what your motivation is. What are you focusing on day to day? Like as a product engineer or like infra engineer, you have usually like a goal of what you want to work on, like a product, a new infra service. You're not always testing day to day. You have something in mind that you're building towards, and kind of aligned on this is the right thing to build. For growth engineers, a big difference is you don't know exactly what you want to do. Like you want to get more people using your app, get more money, etc. But you don't really know exactly what you need to do. And so a big difference here is growth engineers, really a lot of it is just learning what actually works. What is the right thing to be focusing on? And the way you learn here is by running a bunch of A/B tests. Usually you're making a bunch of small changes. So I think like a lot of times you'll hear like, oh, just change the color of a button from blue to red, run A/B test. This is what growth engineers do. Kind of, but really like the motivation here isn't just changing a button to get some more immediate wins. The main motivation is you make some changes, see, is this change relevant? Is this change actually increasing the metrics that I care about? If it does, that implies continued focus on this area is what's important and what you should be focusing on. So a lot of times growth engineers, here we have like, 30% of code that you write will be around in 1 year. You're writing a bunch of code that doesn't really matter. The code itself doesn't matter. What matters is the learning. As a product engineer, you're going to be writing a lot of code that you expect to stick around. You need to make sure it's maintainable. It's not going to increase a bunch of tech debt. But as a growth engineer, you're just kind of running a bunch of tests. What you're actually writing doesn't really matter.
All right. Thank you both. I think that is a great framework to think about what is growth engineers. And let's go to some concrete examples of what actually, especially Marcos, what he did at Meta with growth engineering. So do you want to talk about kind of the principle here?
Yeah, so I think it's pretty similar to like what I mentioned before of as a growth engineer, what you're doing is you're running the simplest test that you can write in order to determine like the next direction that the rest of the team should be focused on. So you're not focused on building a huge skyscraper that's going to be super maintainable and not going to fall apart. You're building a tent, so sleeping overnight. If it's not there the next day, whatever, you got what you needed for that day.
Let's go to the first case.
Yeah, so one of the tests that we ran on the gaming team at Facebook was Here you have like Candy Crush or all these web games at Facebook. In the middle of the page, you have the main game that's loading. On the right, you have a bunch of recommendations for the game. And so like on the gaming team, we own the platform for, you know, the game and the whole recommendation system. So next slide. While on team, we were trying to get more people to play games, get people to spend more money on these games. So one hypothesis we had was if we make the game load faster, we should get more people playing the game, right? The difficulty there, though, is it's actually kind of hard to improve loading speed. At a time, it's like maybe like 2-3 seconds for the game to load. Improving it beyond that would be pretty heavy lift, probably few months of work, if possible, to even get it to improve. But we want to know, like, is it actually worth it? So what we decided on was kind of like doing the opposite. So rather than testing, okay, if we make the game faster to load, is it better? We did what's much easier to do, which is artificially slow down the game from loading and then test that. If it gets better, then that implies probably performance actually matters. But if it doesn't, then maybe performance does not matter. So what we did here was we tested 4 different variants. One is the control, no change at all. One is we changed the main game from loading. One is we changed just the recommendation on the right from loading. And then one is we changed both of them to be slower from loading. What we found was actually pretty interesting, which is if you just slow down the game from loading or only the recommendation on the right from loading, there's actually no difference at all. So here it's like an extra, like instead of 2 seconds to load, maybe it's like 4 seconds to load or 5 seconds to load. As long as the user sees something, that's actually the same as if everything loads. So if you slow down both the game from loading and the right column from loading, then we actually saw a drop in users. But as long as there's something for them to see, it didn't end up actually mattering. So what this implied was it's probably not worth decreasing the time to load from 2 seconds to 1 second, because increasing it from 2 seconds to 4 seconds actually made no change at all. So rather than wasting 3 months improving performance, we were like, okay, not worth it right now. Let's do something else.
Nice. And any question so far on the what is growth engineering and this particular example? And Sid, I'll rely on you to gather questions from the audience. Otherwise, I'll just proceed.
Oh, sorry, I already went over this part.
Yeah.
Cool.
Second case.
Yeah. So the second study I have was on the gaming team as well. We also had this ML system. So like on the previous slide, we had like the recommendations on the right. That was like powered through ML. So it's like based on this user's past experience, which games they've played before, which games they're playing right now, what games should we recommend to them? Sort of what this like objective function for the ML looked like is this is like f of x equals a of x plus b of x plus whatever plus c. And then maybe a of x here is, okay, maybe what game should you play? Like what's the probability of you'll play a game right now? B of x might be like, what's the probability that we think you'll come back to play the game the next day? So it's just like a bunch of different like ML models. Not literally looking like this, but conceptually, something like this. So here we have this ML model. And so we kind of assume, okay, if we make improvements to the ML model, we can get more people playing games by giving them better gaming recommendations, right? The problem was it kind of was a legacy system. No one on the team really understood how the ML system on the team worked. But you know, if it's actually going to drive metrics, it's probably worth learning how to do it. But is it actually worth spending a few months to get someone to get ramped up on how the ML system worked? So similar to the other case study, similar to the other case study, it's you know, is there some easy way to determine, is this actually worth doing right now? And so the way we wanted to test this was, okay, let's just make some simple trivial changes to the objective function. So next slide. So here, for example, we have this objective function. We make a test where for some parts of the objective function, we increase the weight of that part, or we just like increase a constant value, or we make it so, for example, if we have a of x plus b of x, get rid of b of x. So we ignore things of Do we think the player will come back tomorrow? We only care about if they will go and play the game today. So here it's just the assumption is if we make some radical changes to this objective function, and we see some changes that implies the ML model is actually super relevant to the number of players playing the game, the amount of revenue being made. If we make all these changes and there's no changes to metrics, that implies even if we make it much better, there's probably going to be very minimal changes, and so probably not worth continuing investment in. So we found from doing these tests was, actually it did matter, and one of the variants was actually like an increase of like $20 million of yearly revenue for this business. This business is making like billions of dollars a year, so $20 million is like not like huge, but not bad for a few hours of work of just testing out these variants. But beyond like the $20 million per year, the more important thing is here, if you go to the next slide, like here is just like me, I have no idea how ML works at all. I just see these objective value functions and I go like, okay, if I make some changes here, let's just see what happens. Like if me, who knows nothing about ML at all, can make a change and get $20 million a year win, probably someone that understands how ML actually works or spends time to actually learn it can get a much better win. So it's actually worth the investment.
Nice. So it's really the tent here. Like you doing it the simple way. It's the tent, and someone spending time, the investment to do the actual like much better machine learning is the skyscraper. But your tent informs the investment.
Exactly.
Great example. Alexey, do you have anything on like what is growth engineering that you want to add?
I mean, those are great examples. I see a couple of questions in the chat. Like we're talking about best practices for scaling growth engineering. I think that's a great question. Like honestly, that's like worth its own talk. I think Statsig has something like that coming up. So be on the lookout. To Kevin's question, you know, A/B testing, like in what quantity of volume can we make conclusions? I mean, you know, minimal detectable effect is is another complicated question worth going through. I think like it's really nice to have the kind of experiment framework that gives you tools to ultimately see like what kind of volume you need to make conclusions, which again, not shilling for Statsig here, but like, you guys make that a bunch easier. So thank you for that.
I love it. And let me just very quickly go to this one. And I particularly love this. A/B tests are bread and butter for growth engineers. And yes, the reason we invite Alexey and have Marcos talk about this is we believe this, and we give all the tools to make it easy for growth engineers. Okay, all right, let's go to Alexey's part, growth engineering in the age of AI.
All right. So I'll start by saying no one knows anything, right? So this is going to be my best guess on the examples that I've seen thus far. But like, as everyone knows, like the state of the industry is moving fast enough that all these predictions are going to be, we're going to look back and see how silly we are, but still worth guessing. So the first thing I'll call out is growth engineering today is still writing a lot of code, and AI is now like LMs are helping us code faster. And you know, these days I'm a big fan of Cloud Code. It's what I use for day-to-day, like when I need to get it in the code base. But it's sort of, it's the worst it ever will be, right? I think like OpenAI introduced Codex, like this week, last week, and like already that's supposed to have a big performance improvement. Again, like GitHub Copilot was already cool, then Cursor was, like you just see the speed of evolution here. Like software engineers, like growth engineering requires software engineers, and software engineers are getting a serious boost from AI. So if you go to the next slide, I think the particular like LLM-based coding helps growth engineers more than traditional software engineers. So if you look at purple as like the traditional like productivity boost we're getting today, growth engineers get a disproportionate boost because we're often hitchhiking, which means we're in a code base we don't know. We're just popping in here because we want to make one change. And the AI is actually faster than I am at this point to figure out exactly where in the code that is and how, and like getting a first draft of that. It's also really helpful to go across languages. Like I am not an iOS engineer, but I'm able to go in and make iOS experiments now because, well, it turns out the AI is like much more of a polyglot than I am, and I just need to review and make sure that things are fine. The last bit that like stacks with that is a lot of growth engineers are relatively small self-contained front-end changes. Not all, but like many growth engineering experiments will be like that. And that requires writing like front-end React with just enough like design taste to like, you know, not offend anybody and get through the PR. Like my design taste is not quite that good, and like my front end may not be that good, but actually the AI's is. So if you go to the next slide, like you can get to stack those productivity wins, and we like actually like a growth engineer even today gets way more help from LLMs like when writing code than a traditional software engineer. So if you go to the next slide, this sort of the I'll do sort of like a comparison. So at MasterClass, we were really happy if we got 1 to 2, like if we got an experiment launched per engineer per 1 to 2 weeks, spend time on building, testing, etc. But one of the companies I work with now, Fixer AI, if you go to the next slide, I chatted with their first growth engineer, and he's shipping stuff absolutely every day, right? And that kind of velocity is just absolutely crazy. Partially he can do it because it's just him. He knows the code base. He's going fast. And partially it is he's leveraging AI. So if you go to the next slide, there's sort of this AI enabling trend that's the rise of the super IC, where like one person can now do what a team used to do. And I'm starting to see anecdotal evidence of that being true in growth engineers, where like a single growth engineer can now ship, like assuming they have the right tooling, the right foundations, ship like an order of magnitude more experiments and still have time for tech debt, et cetera, et cetera, et cetera. Let's see. Let me take a pause for questions here. But yeah, actually, let's do the next slide and then questions. The high level thing is, I think it's not crazy to say there's even today a 3x like productivity benefit. If you are the first growth engineer and just trying to get a lot of stuff done, like I think that is not a crazy claim, and I think that will only improve. All right.
Nice.
Let's
Well,
look
you
at these
look
questions.
I'll add one point here. Like it's not only the motion, right? It's the progress, and we have the famous poster about don't mistake motion with progress. It's like the reason we do so many experiments is because back to Marco's point earlier, we want to test which ideas work, and we want to have the readout. We want to have the data to understand. And that's how we are applying Statsig. We give you the tool to not only build things fast, but also test things fast. So you can actually get to the direction from this.
Yeah, looking at the two questions, I think like to summarize them, one is, what do you do if you don't have enough data to run like reasonable experiments? And two, what do you do if other teams are like just don't want you to like build tents in their nice neighborhoods? And those are absolutely fair questions. That is an organizational problem and less of a technological problem. Like it's absolutely right to ask it. And in fact, I cover it in pretty good depth in the Reforge course. So again, like, to take a turn plugging myself, course.alexeymk.com. Like we talk about these are very real problems. But like in this talk, let's focus on like what is possible, assuming you can get the organizational buy-in and the numbers to make things work.
Oh,
Cool.
I guess
All right.
one thing for the numbers to make things work, if I can give a quick comment there. So I think like one thing is, I think it works kind of complementary to like the size of your business, where like if you are a startup, you don't really care about 2%, 3% wins. You want like 100% wins. And so like even if you have low volume, if you're making a change and it's doubling the number of users, you will see that change. Like usually, like that is a big enough effect to get like a statistic result. If you're a huge organization and you have, millions of users, that's when you can care about like 1%, 2% wins. And at that scale, you can get those things. So it's kind of like depending on the size of your company, there's different things that you should be focusing on. So a startup, don't focus on 1% wins where you can't actually detect it. Focus on what are like the big innovations that you should be doing.
Yeah, nice. Sid, Tim has a post. Our head of data has a blog post to simulate what is the required sample size for each level of minimum type of effect, and we can link that post here. Cool.
And I think these are great topics for the Q&A at the end. Let's talk a little bit more about the AI side, then we'll love to jump right into it. All right. So the other big trend that you can do today that you couldn't do 5 years ago is just the level of personalization that is available. I think there's always been kind of this dream of like, oh, like we will use growth engineers to build an absolutely perfect version of the product that like meets exactly the user's needs, and that'll let us like squeeze absolutely just all of the conversion gain we can. But like very few companies in practice have gotten it. Versus today, you look at a company like Character AI, which is basically like a, not to oversimplify it, but it's just like a, an AI girlfriend chatbot. And the product is entirely personalized for you. Like this entire chat is like, this is the dream. This is perfectly personalized to what the user wants. So this was not possible 5-10 years ago, and like it's incredibly successful today. So if we go to the next step, I want to talk through like what are the layers of possible and what happens today. So at the very base layer, the sort of like superficial like subject line tests. Today, a human, like not an engineer, but like somebody is usually running those tests on a tool like Iterable or like Optimizely Web, changing subject lines, changing like CTA buttons. With AI, if you go to the next step, like there's tools like Just Words AI, which allow us to like basically you just hand it over to them and they continuously run copy tests and get your approval of the variants, but basically they like a human only needs to be around to approve. They no longer need to be around to like run it, which now means you can just be running subject tests on everything instead of just on the key surface areas. But if you want, on the second step, a more substantial change, like let's say you want to run an A/B test like the ones that Marcos was talking about. Okay, well, you actually need an engineer to go and write that code and see. But again, if you go to the next slide, with AI, there's now tools like CoFrame, which will effectively go and like act as your growth engineering team and will go, today they can go and make like pretty substantial front-end changes, like both come up with and execute on those front-end changes and just need you to approve. And eventually probably like end up actually just like sending PRs to your engineers, asking them to approve these substantial experiments. So these are processes that are still looking at global maxima. If we go to the next step, we talk about what happens when you're actually doing personalization, right? So if you think about the way that a salesperson works, often it's, hey, here's my leads, here's their state. I have a bunch of templates that I'm allowed to like send. Let me follow up with all my stale leads, by customizing the message a little bit. Today, like this is what salespeople do. There's a non-trivial amount of a salesperson's job is these follow-ups. And if you go to the next step, like actually like these days you can like I haven't seen an off-the-shelf tool for this, but you absolutely can do this with AI. You need a tool like AutoTune, which is a contextual bandit, where you give it certain options and you say, hey, which one do you want to try? And then it goes ahead and sends them off, where you just need some improved templates. And then finally, if you go to the next step, like if you have like fully custom messages being written, this is like sort of concierge service. Today, like humans are doing this, like for very, very high touch sales, account executives are writing very fancy emails. If you go to the next step, like I think that's kind of what Character AI has done. They've done it in-house. I don't think we have tools for this yet that are off the shelf. But if you build a combination of, you go to the next step, like the magic to make this work, no, that's exactly right, yeah, is this sort of like two technologies. One is the contextual bandit, which has been around. And then the second is the LLM. Now, I can explain these, but we have YZ on the call, who's a data scientist, who can explain this, 100 times better. Can I pass this over to you?
Oh, thank you, Alexey. I think you really hit the nail. Like before, we have kind of two loops. One is the online experiment. We optimize user data, user behavior data. Like, do you come back? Does it increase revenue? Do you convert more? We have the offline models. We increase model precision recall. We increase area under curve. And today, like our picture is perfect. We can put these things together. We can do fast iterations. We can do, like, as you said, perfect personalization. So we can use the user data to help us find the better performing model and have the model do the perfect optimization to kind of take like get the juice out of stone, like find the last piece of the conversion game. Yeah, that's what
Absolutely. All right. All right. So one last bit of thing that I want to leave folks with, if we go to the next slide. I want to talk about agentic loops. Everyone's going agentic. It's all the rage. And what you're saying is basically like how much, to what extent can I hand the wheel over to the AI, and like at what point do I need to go be a bottleneck? So if you think of, if you go to the next slide, like here's a traditional like growth engineering process, right? We come up with a lot of ideas, we prioritize the ones we like, then we do some like high level designs, come up with some copy, then we implement them on the engineering side. We launch them, we collect the data, we analyze both to see whether it won, but also to see like what are the insights that we can glean from the results. And we feed that back into generating more ideas, right? So this is just how a growth engineering team will work. If you go to the next slide, the bottleneck today is largely in engineering capacity, right? So we only have so many engineers, they can only launch so many experiments. Like in practice, like the bottleneck is engineering. However, if you go to the next slide, like if you imagine you have like a CoFrame or a JustWords or any one of their competitors that's doing the loops, they are not bottlenecked on engineering implementation. They can implement anything in a minute. Their bottleneck is actually approvals, right? Because you don't want to fully hand over the reins to one of these AIs, because like if the thing they're optimizing for is people clicking the button, they will eventually just make the button text say like get free money, right? You need to have some guardrails, and at some level, those guardrails still need to be on a human level to make 100% sure that you're not hurting the brand, that you're not violating those guidelines. So we have moved today, like even in the world today, for the classes of experiments that you can do off the shelf with AI now, the bottleneck is moved to experiment approval. But if you go to the next slide, like let's just take a step back and just have a thought experiment of what the world looks like in 5 years, right? Where something like a Devon is fully functional and can both come up with experiments and fully execute them. You still have like two places for approval. One is like, is this experiment a good idea? Like, do I approve of it? And the second one is like, okay, given that I've approved it, can I actually can somebody review the code if this code is actually going into the code base to validate that it's done everything correct, that it's not going to create tech debt, et cetera, et cetera. So you still need those two steps of human approval, but otherwise you're kind of good. And if you go to the next step, the next slide, like I actually, I think it's LLMs all the way down, right? I think at some point, if you have a brand team that needs to approve all experiments that touch the homepage, okay, at some point that brand team was going to build an LLM agent that approves 95% and then only escalates to a human being for the last 5% of approvals. And similarly for engineering, like if you're going to have if the job of an engineer becomes more and more to like review tickets generated by AI, at some point we're going to make an LLM agent that's just going to review tickets and just like have permission to approve the 95% that it's confident about and only escalate to a human for the 5%. So I think truly if you trust that the quality will continue to improve, I don't know what the bottleneck will be. I think growth will just be it's going to be somewhere, but every problem I have come up with, I trust that we will solve. And again, 5 years is kind of a guess. Maybe it's 18 months, maybe it's 3 years, maybe it's 5, maybe it's 10. But all of the fundamental bottlenecks are about to be broken, and I'm very curious about what's coming.
This reminds me of an interview I saw with Cursor's co-founder. Cursor is the web coding too. And his opinion is it's the taste that actually matters in the long run. Like, yes, we are going to unblock a lot of bottlenecks, and probably the bar is going to be higher as a result. But then the differentiator comes from the taste of a human. There is still a human in the loop, but not doing the trivial work that can be automated, but increase the taste and finding kind of the brand story, the user, the distinct factors.
Exactly. Until we have a taste agent, and then no, I'm not serious. Okay, let's jump into Q&A because I think this is about as much as I have. Let's
Nice.
see. Sid, let me hand it over to you.
Yeah, I think I saw a few questions on the chat, but folks can use both the Q&A and the chat option to send across your questions, and we'll hang around for the next 10-15 minutes to answer them. Did we get the questions earlier on in the chat? There was one from Yifan as a growth engineer, we always need to make changes in services owned by other teams, and they usually do not like us building a tent in their land. Does it mean we need to work with them to maintain a playground where growth engineering can build tents besides the skyscrapers? I thought this was a pretty interesting question.
Marcus, you want to take that one first?
Yeah, I think Alexey touched on this one a bit earlier on. I think it is an organizational kind of thing of I think probably the most effective way is you do just get alignment on, yes, this growth engineering team has some sort of budget of, how much could you potentially regress certain metrics, how much are we willing to compromise on what is like the established brand. Like growth engineering teams don't work well if it's every single experiment I want to do is, 3 months of some meetings. And so I think like the only effective way to do it is you get alignment on, you can run these tests very quickly up to some sort of reasonable standard.
Yeah,
The-
I have an example, and and the second example is Alexey's example. The first example is when I was at Facebook, I started working as a product data scientist, but then the growth team adjacent to us doesn't have a DS, so I was working as their DS for a while as well. And that was in their meetings. And I hear like that was an awkward position because they were constantly talking bad things about each other. Like the growth team would be like, product team doesn't want this us to do this, they're too small. And the product team they were crazy, they were doing experiments that would hurt our long-term business. But yeah, overall, I think I learned that it's useful to define the budget. Like this is a budget, go run with it, but don't do too much. And second, have some overall principles. And third, you can get some swim lanes. Like for example, I was working on a seller team, and the growth team was working on seller growth for Facebook Marketplace. And so the growth team owned the upper funnel, like how many people actually before a seller activation, and then the product team owns after the activation. And with that, I think people can generally get alignment on high level things. And the second example is Alexey, your pricing experiment, like that one, like especially promotion, right? That was like a product would not do that, but it's okay for growth to do.
Yeah. Let me touch on that. I think let me first step back and say, I think if you find yourself at the growth engineering team constantly like stepping on other teams' toes, like your org has not been designed for success, right? I think the first thing to say is like, actually for the things that growth really wants to touch a lot and thinks is a really high leverage surface area, just give it to growth. Like it is cheaper to have growth pay for the maintenance and the bugs of the surface area because now they don't need to go to another team for like reviews. Just like hand them that entirely and then try to make it that when they do have to hitchhike across the surface area, that is the exception rather than the rule. So that's really like the first thing. Like everyone's gonna ship their org chart. You might as well try to build like a system design that like gives growth like most of the interesting surface area that they want to do when that's possible. To your point about the pricing example, I think there like we had an experiment idea that like if you were to just ship it and see if it works, then it would have taken all of engineering like months to do, and like growth could not have done it themselves. But we found a way to scoop the experiment down into a fake door where we could touch only our surface area, and that like as a result, like we didn't have to go touch their code because we were able to find a way in our surface area to learn if things worked or not. But yeah, the other bit is like cheat. I think like if you have to hitchhike into somebody else's surface area, make sure there's some executive sponsor that really cares about it that's in their org. And so then like when you go do it and you demand like, hey, like can you review this within a couple hours and not like 3 days, that like that's coming from the executive who really cares about it, and they're mad at that executive and not at you. I think that also really helps.
Nice. It's very practical tip. I have a question myself for you, Alexey, because before a lot of people ask me like, can you refer a great product marketing manager? Sorry, said today a lot of people ask me, can you refer a great growth engineer? Especially a lot of AI startups, they have maybe 10, 20 people, and they are really looking for a growth engineer to help them grow their product, and they pay pretty well. I don't know if that's our observation, and why do you think is that a trend, and if so, why it is?
I mean, the interesting thing about growth engineers is it's such a new job title that it's very hard. Like, it's not hard to find engineers that are entrepreneurial and would be good growth engineers, but it's hard to find someone who's actually done it before. And there's a small number of places where the alumni are really good. Like the Facebook alumni are really good. The Pinterest alumni are really good. I think Airbnb, Netflix have particularly strong growth engineering arms. And like, the last time I visited the Bay Area, I popped by the OpenAI and Anthropic offices and like looked who's there. And it's like all my friends from when I was at Facebook. It's just like the old gang coming out of retirement because AI is so exciting. So to some extent, it's hard to get them because OpenAI and Anthropic have already hired all of them. But other than that, yeah, like if you can't get somebody from one of those early places, I mean, like my favorite place for a new growth engineer is somebody who just did a startup, with the CTO, they went through YC, but it didn't work out and they want to figure out what they want to do next. Well, like I think growth engineering is like the world's best retirement program for technical co-founders.
Interesting. Marcos, do you have some old friends from Meta? I guess the real question is, at your time at Meta, you would consider yourself as a growth engineer, right? And how many people are actually in your mind fit into this archetype?
I mean, I think it's kind of similar. I think not that many people, like even at Facebook, most people don't really do growth engineering. I mean, I actually wouldn't consider myself a growth engineer, more like an engineer that enjoys growth engineering. Yeah, I think even at Facebook, it's pretty hard to find explicitly growth engineers. I think what Facebook does a bit better is like, even if people are not growth engineers, they still like take growth engineering ideas and like implement them day to day. And like you'll hear like being scrappy and things like that. I think like being scrappy is very similar to being a growth engineer, where like you can apply that even to infrastructure, even to product building. Of if I'm building a new infra service, do I build this perfectly from the beginning? Probably not. Build like what kind of whatever works first. You test out, does this work at a large scale? If it doesn't, make it better. If it does, all right, good enough for now, move on. Yeah, I think also all the good, like all the like growth engineers at Facebook that I worked with probably just hired them here already.
Nice.
Yeah, it's also a mindset. Yeah. But,
Yeah. Yeah, love hearing that. I think, Alexey, we should make a throw pillow with what you said about growth engineering as being like a great retirement for a former YC CTO. But I think, jokes aside, I think you all touched a lot upon, this idea of like making it very simple to like test an idea and quickly get feedback and learn. We had a couple of questions which are, I think, kind of related to, after running the test. And these were from Bilal and Keaton. And we kind of touched upon this, but it might be worth, double clicking here. So the questions are, what helps you determine whether to move on from an experiment versus, trying again and iterating further? And also sort of related on, test duration is like Keaton asks, but if it takes 10x the time to get the result, who has the time to, run a test for months? And maybe this, just gets to like faster experimentation as well. So, I think all three of you could chime in, but maybe Alexey, do you want to go first, and then we can bring in Marcos and YZ as well?
Okay, those are two questions. Let me try the first one around like when do you give up on an experiment? I think like it depends. It depends is the worst answer, but it's also true. I think it's it depends on how much confidence you have that it should work. So if you've used something like an ICE or a RICE framework to score the experiment, and you have high confidence that it should work, like this works at every other competitor, or like this has worked at like 5 other surface areas, like, for us, but it's not working here. Like, yeah, you should probably give it a couple more attempts and like figure out what's wrong. If this was just somebody's crazy idea, like you tried it, it didn't work, like, if you don't have that much conviction, like, you don't need to throw good money after bad. So it just depends on your level of confidence. What was the second question?
Yeah, the follow-up to that was from Keaton on, just like sounds like they were struggling to the tests were taking too many months to run, and so then it just, it doesn't make any sense if you're running an experiment for 2, 3, 4 months. So I don't know if Alexey, you want to take it, or YZ, you want to come?
Yeah. I promise I'll let other folks speak, but
No,
I mean,
Alexey, I want to hear your opinion, but I do want to share a lot of things, but I want to hear your opinion first.
all right. So again, like use a prioritization framework. Again, like RICE is pretty good. Like I have an article on Lenny called DRICE, which I quite recommend. The idea is like when you are evaluating how good an experiment is, part of the evaluation is like, like how big of a win it will be and how long it will take to run. And if an experiment will take 3 months to run, then like that should lower its score. Like the only way you are running an experiment that's going to take 3 months is if there's some like crazy extenuating circumstance for why you believe it. But yeah, it should probably just get ranked lower. And also like if you really believe in something, but it takes too long to prove, like A, you're probably an earlier stage company, and B, just ship it, right? there's nothing wrong, especially earlier on, just ship it and then do a pre-post to see what the impact is. Like, not everything needs to be an A/B test. It's fine.
Yeah, this is one of my favorite topics because first, I have a different opinion than a lot of data scientists. I think I'm more practical experimentation. So to answer the second question, how to speed up experiments, I have a blog post coming up. The title is Speeding Up Experiments with Discipline. So you can go to Statsig and search for my name, Yuzheng, and follow the blog, or you can go to my LinkedIn. But basically, there are a couple of things. First, you want to run overlapping experiments. You want to run concurrent experiments. So instead of one experiment, you want to run multiple experiments at the same time. And the interaction effect is not a big deal, unlike a lot of data scientists would tell you. And I have articles to help you for reference. We can prove this empirically and theoretically. We also have tools to help you make sure it's okay. The second is you want to find proxy metrics. Like if you just want to look at how much does your experiment move revenue, most of the time it cannot be significant or it's just too noisy. But if you look at some like for example, impressions or how many people enter the product detail page, how many people click on the call to action, you get a faster rate. So that is useful. You also want to use statistical tools, which is out of box from Statsig. For example, Cupid, to reduce your variance and really boost your signal. There are a couple of these kind of tools to help you do that. And Alexey, like the first time I met Alexey, he just finished advising someone using Statsig, and his conclusion is sequential testing should be default on. You should use sequential testing. That's where with discipline, you don't want to do a lot of false discoveries. You actually want to use tools to help you make conclusions with discipline. And so my post is about this. There are a lot of things you can do to speed up your experiments. But more importantly is understanding what is experimentation. Experimentation is not have a result and let the number tell you, A is better than B, ship the larger number. Experiment is give you the causal evidence on some effect. You have the observed effect, but it's on you to infer, to interpret the results and make a decision. A lot of time, like data is like the data you can observe in an experiment is not the whole truth, right? And then the qualitative data is not the whole truth. You need to bring your own judgment, and you need to try to just make a decision observing the effect, like looking at the observed effect. So one quote that I like a lot is, everyone is doing experimentation, but some people have the control group. So everything you launch as a startup is an experimentation. You just launch to 100%. When you have the luxury or when you have the infrastructure to have a control group, get some reading, that is a good thing, but do not have that number limit your choice or limit your decisions.
Yeah,
One
great
thing I'll add to that. Oh, sorry. Oh, just one last point on that. Like for folks that don't know what sequential testing is, it's very likely that if your company is not using sequential testing, your like false positive rate is way higher than you think you are. You are almost certainly peaking. It's kind of crazy how often this happens. So I run a dinner series for heads of growth engineering. Anytime I'm in SF, it's like a dozen like heads of growth engineering from large companies. Also, if you want to join, just send me an email. And we did an interview with a data scientist, and we just did a show of hands, like, hey, who knows what a sequential test is? And like, it was less than a third of them. And these are the people who are like running growth engineering orgs at like billion-dollar companies. So like the level of knowledge is low. The single safest thing you can do is just do sequential by default, because then when you do that thing where you run it for 2 weeks and you're like, let's let it run 1 week just to see if we hit our numbers. Like you're not shooting yourself in the foot when you do that.
Oh yeah.
Anyway, sorry, go ahead, Sid.
I just dropped a nice recording of a sequential testing webinar from last year. We called it Test and the City. So that might be a good one for folks to check. Sorry, YZ.
Oh yeah, I just remembered. If your test, like do a power calculation before your test, be very disciplined in be honest with your minimum detectable effect, and then you can calculate the sample rate, sample size required, and the duration required. a lot of time people are frustrated with experiments running for 3 months. It's because they thought I can get a positive lift after 3 weeks. And then after 3 weeks, not significant, they want to prolong the experiment. If you do the practice before you start the experiment, you will realize, okay, the idea is not good enough. So we should find better ideas. We should do iterations. It's not that experiment is taking too long. It's just your idea didn't drive the positive lift that you expected to have.
Yeah, great points. I think how are we doing on time? Do we think we can take 2 more quick questions, or do we want to wrap things up? We're good? Okay, I like this one, and maybe this one's a good one for you, Marcos, as also head of engineering for Statsig and hiring and building a team here. This one's from James. The question is, are there different skill sets for growth engineering at different scale levels? I guess working at maybe a smaller company, and then as it grows, what do you think about the most important skills are?
Yeah. So I think I touched on this before, where if you are a small company, you don't want to be focusing on 1%, 2% wins. You want to be doing more revolutionary things. And so if you are a startup that has 100 users, there's no point on iterating on the text that's on button that's going to generate a little bit of wins. You want to test if I do this radical thing, am I actually going to 2x my number of users? Am I going to 10x my number of users? As your company grows in size and a 1% increase in revenue is now millions of dollars, then now, yeah, probably you want to start testing very small changes, because any 1% makes a huge difference. And also you can also measure this effect. And so when you should be focusing on what is important for the business right now. Is it these incremental small wins, or is it I need to find what is the right drastic new direction for the company?
Anything to add, Alexey or YZ? We have one more question before we wrap up.
My one big complaint to that is talk to any growth engineering manager, and it's a giant pain in the ass to get your engineers promoted, because especially at bigger companies, career ladders tend to focus on complicated technical achievement, versus a growth engineer is successful if I made to all Marcos's point, oh yeah, I made a 2-line change and it was $20 million of revenue, right? But you can't put that on a promo packet. So there's this weird incentive structure of how do I incentivize the behavior that I want? And that problem becomes bigger as the company gets larger. So no one's quite nailed it.
I guess one thing there is I guess if you're thinking about your own engineering level, I guess the main thing there is probably the influence. And so a lower level growth engineer, they're just running a bunch of tests and seeing hey, here are the results. I made some immediate wins, yes or no. I guess a higher level growth engineer is more okay, I'm running these tests not for the purpose of the immediate wins, but for the learning. And so I made this test, and it is maybe a 2% win for number of daily active users. Therefore, we should do this. I think that's how you kind of say this person should get promoted. Of you're using these growth tests as a way to influence the direction of the team, of the company, rather than just stating this is the result.
I'm so jealous that you spent so long at Facebook, which is one of the very few companies that gets this right. This sucks almost everywhere else, man.
True. I remember McDevlin's talk of why people chase technical complexity over impact. That was because in school we learned that harder things are more valuable, but that's not true in business.
Yeah, I remember just a couple of weeks ago, we did a case study with one of our customers called Runna. They're a running app that recently got acquired by Strava, for those of you who are familiar. They're fairly small in terms of 100 to 150 employees, but their growth engineering team runs a ton of experiments, and they try to add more steps to the onboarding flow, where they were capturing more details from the users. And they thought that this would actually reduce sign up conversions and activation, but they actually learned that counterintuitively it improved activations, because turns out people who are downloading Runna wanted more personalization, because they thought that, oh, by entering more details about my age and other things, we are actually, this is a better personalized running coach for me. And that sort of pivoted their strategy into like what they were doing, as a company. So it was a very simple experiment. Hopefully you publish that story soon, over the next few days. But like, I think it's really cool to see that, companies, it sounds like companies across the board can really benefit from this. It's not just like for the Pinterest and Facebooks, or, I think it's like YC startups all the way through big companies. Okay. James says higher level of growth engineering might be a founder eventually. Guess that's true. Cool. One final, I know Alexey's dropped some good resources there. We've been dropping a ton of resources on the chat. One final bump for, for folks who are looking to learn about Statsig. A good way is to join our monthly demos that we do. The next one's taking place on June 12th. So I've just dropped that link on the chat for those who are interested. This webinar was recorded, so we will share it with all of you within a couple of days. And then I'll also try to see if we can, compile some of these questions, because I think there were a lot of good discussions here, and maybe we can share them out as a blog post in a few days. But I guess before we wrap up, any final thoughts, any hot takes from the three of you today? YZ, I'll let you go first.
I don't have hot takes, but now I feel like I'm privileged to have worked with so many great growth engineers. And I feel like it's not only working on growth, right? It's a mindset of being scrappy. When you say like when the comment great growth engineers became a founder, I immediately thought of Vijay. He is the growth engineer. Yeah.
Alexey, any final thoughts from you? Any hot takes?
No, just a request. I think like I kind of shared all my hot takes in the talk. If you are trying to figure out how to leverage AI in your growth engineering like day to day, and you have something interesting, send me an email, right? Just alexey@alexeymk.com, or just you go to alexey.com and submit the form. Like I am very curious to see what people are doing in the wild. Happily shout you out, like reshare your stuff, however you want to get feedback for that. And then if you are a growth engineering team and you're running into sort of organizational problems, scaling problems, like, well, actually, this is exactly the kind of advising that I do. So if you need someone to talk to, I am also around, happy to help.
Marcos, final thoughts from you?
Maybe I have a hot take. I don't know.
Oh, nice.
So I think like one like meme at Facebook was for data scientists, the easiest way to get promoted was get a team canceled or get a team like defunded by proving, "Look, this team doesn't matter." I think that's kind of could also be true for growth engineers I mean, a big part of it is learning. And so like you can run tests where you're not trying to actually improve a metric, you're trying to run a test to decrease a metric. And so like if you can prove, if I make this change, this is a worse change overall, and maybe this change is testing what the company is currently moving towards, that can actually say like, okay, don't continue investing in this thing. If we keep investing in this thing, it's going to be worse. Invest in this other thing instead. So maybe an easy way to get promoted as a growth engineer is, get teams defunded.
That's a great hack.
Well, I think there's no better way we can, end the webinar, right? That's like the perfect parting thoughts, I guess. But thank you so much, everyone, for joining us. Great discussion today. Thank you, Alexey, Marcos, YZ, for like driving this. We'll send you folks the recording within a couple of days, and hope to see you at like future webinars. A lot of great programming lined up. So take care and bye for now.
Thanks for having me.